Welcome to Maths with EJD. We are gradually drawing to the close of game theory. It's been a very jolly ride. But before that, we have like 3 videos to go. And here we'll be talking about dominance solvable games. And because we can actually approach dominance solvable games either sequentially or simultaneously. So I'll make this video on the sequential approach. In the next video, we'll be talking about the simultaneous approach. And after that, we'll be talking about repeated games and strategies. And we would have brought game theory to a close. As far as now is concerned, if I find something important later on game theory, I can continue the playlist. And that will make like 35 videos, interestingly. So if you have not subscribed to the channel, you definitely want to do that and hit the notification bell so you can always be abreast of whatever is happening on this channel. All right. So let's look at the idea. Let's look at the overview of dominance solvable sequential generally dominance solvable games, and then sequential is just the approach to it that we are going to have in this case. So a dominance solvable sequential game, all right, involves a series of decisions made in a specified order. In a specified order. That is what makes it sequential. So that is where sequential comes in. That's sequentially. Sequentially. Okay. So that's the sequential part. But then the other part is where we have the dominant solvable part. So here, where players eliminate, so players eliminate dominated strategies. Dominated strategies. That is choices that are consistently worse. Choices that are consistently worse, okay, than others. Choices that are consistently worse than others, regardless of what opponents do. Regardless of what opponents do. Okay. Of course, this is going to that is done step by step, and that is why that's also referring to the idea of sequential. Okay. Now, this process, okay, I guess I want to change markers at this point. This process reduces the game. This process reduces the game to a single optimal strategy, to a single optimal strategy for each player. For each player, for each player, right? So in sequential games, the timing of decision matters. The timing of decisions matters. The timing of decisions matters. And dominance solvability, dominance solvability, and dominance solvability ensures a unique outcome. A unique outcome through backward induction. Okay. All right. So let's just go straight to take an example that we'll deal with. So, of course, when you're solving a game, you're ultimately looking for the Nash equilibrium, right? So let's take this example. imagine that so example, imagine we have two players. We have player one with strategies. Okay, let me say player A. Okay, we have player A with strategies A1. Let me bring that down a little bit so I can have some space. So we have player A with strategies A1, A2, and A3. And we have player B with strategies B1, B2, and B3. So, and of course, their payoffs are as follows. We have 3, 2, 3 for player A, 2 for player B, 1, 3, 1 for player A, 3 for player B, 4, 1, 4 for player A, 1 for player B. Then we have 2, 1, 2 for player A, 1 for player B, and so on. So 2, 2, 3, 4, 0, 3, 3, 4, 1, 2. So this is the payoff matrix for the two players. So player A has strategies A1, A2, A3. Player B has strategies B1, B2, B3. So we want to solve this, so we want to use the dominance solvability approach, and we want to be sequential about this. Okay. Uh the goal is to eliminate dominated strategies for each player turn by turn, okay, until a Nash equilibrium is reached. Okay, that's our goal. All right, so let's go ahead and do that. So solution now. So sequential is key here. Going sequentially is very important here. So, and what that means is that player A will eliminate a dominated strategy, then give it over to player B to continue. After player B has eliminated one, player A will do it until we reach the Nash equilibrium. So here, let's see. So we have again 3, 2, 3, 2, 1, 3, 4, 1, 2, 1, 2, 2, 3, 4, 0, 3, 3, 4, 1, 2. Okay, this is what we have now. And this is player A. So this is A1, A2, A3 for player A, and this is B1, B2, B3 for player B. So the first, okay, should I have called this first iteration? So this is first iteration, or first elimination, and the first elimination is going to be carried out by A, okay? So the focus is on A right now. So what is A going to do? A is going to compare its strategies to see whatever B does, A is going to compare strategies. So let's go for that. First of all, imagine that we are, we can compare two strategies at a time. So imagine that we are comparing strategy A1 and strategy A2, in the first round of elimination. So what do we do? So for all the strategies of B, what are the possible payoffs for A, across the strategies that B may come up with? So you know what I'll do? I'll just come over here and just write. So A1, we have A1 versus, we have A1. Okay, well, we already know this A1 versus A2. So how do they compare? So let's check one after the other. So for strategy B1, so you see, so A1, the player A, sorry, I think this is better. So player A gets 3 against 2 here. So the 3 is bigger. Player B has a better chance with A1 in that case. Then if you go to strategy B2 for B, so player A gets the payoff here is 2, but it is 1 here. So 2 is better. Then when we go to strategy B3 for B, player A gets 4 payoff of 4 for strategy A1 and 3 for strategy A2, but 4 is bigger. So at the end of the day, if you compare, right, you see that you'll discover that A1 yields two dom, two domin two how do I put it now? Let me say two better payoffs, okay? Two better payoffs. Okay, that's what I'm saying there. And then strategy A2 yields only one better payoff. Okay. Overall, what do we say? Overall, we see that strategy A1 dominates. So we say strategy A1 is greater than strategy A2. This implies A1 dominates A1 dominates A2. Okay. So that simply means that as far as player A is concerned, we have to eliminate strategy A2. Okay. So in that case, we have to cross this out. We have to cross out strategy A2. We don't want strategy A2 anymore because it's inferior to strategy A1. Okay. So that is the first elimination, and A has taken charge in that case. So when we go for the second elimination, that is going to be B's first elimination, and we would have eliminated strategy A2 for A. So so let's move on to second elimination. So second elimination, that is first elimination for B, right? So for second elimination, see what's going to happen. Now, A1 is out of the game. So what we just have now will be okay, let me just write the payoffs first and then label. So we have 3, 2, 1, 3, 4, 1. Then we have 0, 3, 3, 4, 1, 2. So now, A2 is gone. So we have A1 and A3 for player A. And then we have player B still has all its strategies, all his strategies intact. So B1, B2, B3 are still intact for player B. So at this round of elimination, the focus is on B. So B is going to eliminate his own dominated strategies, let's assume. So what are we going to do? So what is going to happen here is that for all the possible strategies of A, which are A1 and A3, then player B is going to check his own payoffs. So for instance, if uh if player B is using strategy B1, all right? So across all the strategies of A, so player B will get 3 points for A1 and 0 for A3, and 0 is smaller than 3. So as a rational player, player B will settle for 3 points. Okay. So the next, oh, sorry, that's wrong. Okay. So we are talking about player B. So the second payoffs are for player B, sorry. So if player B considers the payoffs like that. So now, okay, in this case, let's compare B1 and B2. Okay, let's compare B1 and B2. I think it's better to compare B1 and B2. So for B1, player B gets 2 as payoff. I mean, for A1, but then gets 3 down here. So 3 is better. Okay, 3 is better than uh 3 is better than 2. And then when we come over here, player B also gets, so when we come down here, player B has option of 3 points for A1 or 4 points for A2. So we have this. Okay. Now, But there's a bit of issue here. Okay. Okay. Yeah, this is what we should do. So we are comparing B1 and B2, right? So for A1, yeah, for A1, so we have player B can get 2 for A1, all right? But then for for A3, player B can get 3. So 3 goes. See, here we're looking at, so it's 2 against 1, and it's the horizontal. So this has to be vertical now. Okay, this has to be vertical, B2. Okay, yeah, this is what we should be comparing. So for A1, player B can get 3 points here or 2 here, but 2 is smaller, so player B would rather not worry about 2. Then when we come to strategy A3 for player A, right? Player B can get 4.4 points here for payoff and 3 here. 3 is smaller, so player B will go for 4 instead of 3. So in that case, what happens? We see that just like we did at the top, right? Strategy B1 is giving zero, zero better payoffs, zero better payoffs. Whereas strategy B2 is giving 2 better payoffs. Okay, 2 better payoffs. That simply means that, that simply means that strategy B2 is better than strategy B1. That means B2 dominates, B2 dominates B1. So in that case, we can cross out. So in that case, we just cross out strategy B1 because it has been dominated by B2. So this strategy will be gone in the next round. Okay. So this strategy will be gone in the next round. So we go for the third elimination. Third elimination. So since it is sequential, it now goes back to A. But don't forget, we are going to eliminate strategy B1. So the next thing we are going to have will be just this. Okay. It's going to be B2, B3, and A1, A3. So see what happens here. So now we have 1, 3, 4, 1, 3, 4, 1, 2. And that will be for A1, A3, and B2, B3. Okay. Because now B2 is gone. So we just have B2, B3, A1, A3. So this is for player A here and player B here. Now, again, the focus is on player A. So player A is going to eliminate strategies now. So player A only has 2 strategies, A1 and A3. So focusing on player A now, since player A has A1 and A3, so if player B chooses to use strategy B2, so player A has 1 point here and 3 points here. So you see that automatically 3 points are better than 1 point. Okay. Then if B chooses for strategy B3 for B, so player A will have 4 points up here. Okay. And 1 point down here, but 1 point is smaller. So player A would rather settle for 4 points. But you see, the thing is, the two strategies have one payoff better, right? But the issue is, okay, well, let's settle that, right? Here we have, from what we did before, this is one better payoff. So A1 has, so now A1, A3. So A1 has one better payoff than A2, than A3. Also, A3 has one better payoff than A1. But how do we decide this game? You discover that the better payoff for that A1 has is actually 4. 4 against, so it's 4 up here against 1 here, whereas for A3 it's 3 here against 1 up there. Okay, so automatically, though they both have one payoff each, but the payoff for B3, the payoff for A1 is better than the payoff for A3, though they are both 1 better payoff like that. So in that case now, we say um okay, maybe we can say this. We can say that okay, the value of the payoff for A1 is actually 4, okay, you know, and that is greater. Of course, especially if you compare the difference, this is 3 more than the other payoff, and this is just 2 more than the other payoff. So it is 4, and that is greater than the value of the other payoff for the other payoff for strategy A3, which is actually 3 now. 3. So this is 4 versus 1, and this is 3 versus 1 in the other strategy. So in that case, we can conclude that A1, all right, A1 is greater than A3. That again implies that A1 dominates A3. A1 dominates A3. So what that simply means is that we are going to cross out A3. So A3 is not the best way to go. So we have to cross this out in the next round. So the game is gradually coming home. So next we are going for the fourth elimination, which is B's second elimination. So let's go for fourth elimination. Fourth elimination. Okay. So talking about the fourth elimination now, we have just one strategy for A and 2 strategies for B. Okay. So now we are going to have just this 1, 3, and 4, 1. 1, 3, 4, 1. Like that. So this is 1, 3, 4, 1. And this is for B2, B3 for player B. And this is just A1 for player A. But then the elimination, so you see that all the eliminations are for player A and all even the eliminations are for player B. So player B is in focus now. Now player B has, I mean, it's the choice is getting easier now. So player A has only one strategy, but player B has two. So player B has to choose between. So it is sure already that player A1 is going to go with strategy A1, right? But which of these strategies strategies B2 or B3 will B3 go for? So now we are comparing strategies B2 and B3. Okay. I mean, glaringly, if player B chooses strategy 3, I mean strategy B2, the payoff is 3. If player B chooses strategy uh if player B chooses strategy B2, the payoff is 3. If player B chooses strategy B3, the payoff is 1. Obviously, 3 is bigger than 1, all right? So we see that we don't even have to worry about the number of better ones now. So automatically we know that B3 has to go because B2 is greater, B2 is better than B3, meaning that B2 dominates B2 dominates B3. So at this point, we have just this one left. We have just 1, 3, and that is automatically going to be the Nash equilibrium. So instead of the next elimination, no need. We just talk about the Nash equilibrium now. So the Nash equilibrium, we have arrived at the Nash equilibrium. So the Nash equilibrium is simply that point where we have 1, 3. So that's A1 for player A and B A1 for player A, right? B3 was eliminated. So uh B B2 for player B. Okay. So uh player A will go for A1 and player B will go for B2. Let me do that properly. Okay. So now we have A1 for player A, that's 1, 3, and B2 for player B. So A here, B there. So this is the Nash equilibrium. So we can conclude. We can now say, therefore, the Nash, the Nash equilibrium, the Nash equilibrium is such that player A chooses strategy A1 and player B and player B Player B chooses strategy B2 with with one and two payoffs, with one and two payoffs respectively, with one and two payoffs respectively. So in essence, right? In essence, the Nash equilibrium is A1 comma B2, and that is equal to 1 comma 3. So that is the dominant solvable sequential game. Dominance solvable sequential game. So we have arrived at the Nash equilibrium using, so going step by step like that. And so after this game, player A goes home with 1 point and player B goes home with 3 points, whether it's money like 1 million, 3 million, whatever. But that's the best each of them can get from this game following dominance solvable sequential strategy. All right, so that's the end of this video. So in the next video, I'll be solving the same problem using for dominance solvable simultaneous game, where in that case, one player plays all all his game and then hands it over to the second player to play all his game, and then we see if we are going to arrive at the same answer or not. So if you have not subscribed to this channel, you want to do that right away, and then hit the notification bell so you can always get alerted each time a new video is released. Then, of course, you want to comment to let me know how helpful these videos have been for you. And if you wanted to solve a problem or teach a topic, you also want to comment all that. Then hit the like and share so that more people can have access to this great learning. Till I come your way again, keep playing the game of life wisely. Bye.